This is Morten from English TV here at FEFCO in Lyon, and I'm talking to Lars from BHS.
Hi, nice to meet you.
Nice to meet you. Lars, we just spoke about that you have a presentation here tomorrow, right?
Yeah, right.
What is it about?
It's about optimizing heat consumption in corrugated board production and beyond. So I want to give more or less a more holistic view on how to optimize heat consumption, not just at the corrugated itself, but also on the supply side, on the distribution side, and also on the heat recovery side.
So the spot you have tomorrow, is that from a technical perspective? Okay, so the audience, is that like the converters that buy the BHS machines to understand, let's say, the challenges of managing all the things you just spoke about? Or?
I hope so. I hope so. Yeah, that we get in contact afterwards, because I'm in this industry for 2 years now, and I've met many people. So they're dealing with the energy management at their plant, and they don't have a clue what to do, because they have more or less 4, 5, 6 different systems connected with each other, but not communicating with each other. That's a big problem. So if we want to optimize heat, it's important that we get all the things, all the systems in connection, and all the stuff, all the data together, to be able to lower down steam pressures, temperatures, moisture content.
So it is also a matter of minimizing energy cost, basically. Okay. Just a quick question. So let's say that you add too much energy to, let's say, the heater, for example, right? What is the output? I mean, does it hurt, damage the material, or is it just because it used too much energy?
Yeah, both. It's about too much energy being used and too much losses going through the air. But it's also, you can also add too much heat to the paper and to dry it too much. So then you have to steer against it with putting water on it or something. So it's important to find the optimum point. It's also the connection between the heat consumption itself, if you think about the double backer, and the electrical consumption. Because if you are too dry or too cold in the double backer, you have to add more motor or motor currency. You have to add more power on your drive to get loss of the friction.
And of course, since you have something that is very wide, very long, and for 24 hours a day, that of course also plays a role from a financial perspective, how much energy you have for the servos and for the motors and for everything.
Yes, yeah. What kind of shifts you're operating? Is it a 2-shift, 3-shift? Are you operating 24/7 or not? That's also a big point, because what we see is more or less for older corrugators, they operate the vessel, the steam vessel, the whole weekend, even if the machine is not running, because it's easier for them, because a person has to go there, push a button, that it gets started. So more or less that's how to get intelligence into your system, raise the degree of digitization of your system, have less human interaction on your system.
So a level of automation, basically.
Yes, exactly.
Yeah. So when you look at the technology you have in market and also the spot tomorrow here, is it like something that an operator can easily do, or is it something that requires a lot of training to make sure that you get things going right?
More or less, also both. I would say we have to train the operators more to get a feeling how to operate the machine more energy efficient. Because right now it's more or less they have to have their volume produced. They don't care about energy. Thermal energy is about 3% of costs of the package or of the board, and that's a big problem. Yeah. Because it's more focused on volume. It's not focused on specific energy consumption. So what we are aiming to do is the optimum point of kilowatt per hours per net ton output. So that's the point where we are going to go. But then there are going to be new technologies, or you name them, and you need more training, new training. But you also have to train your own personnel, of course, because it's new for them. Like I said before, I'm in the industry for 2 years now, and I've heard that the industry didn't change for 30 years. So right now, everybody is screaming for revolutions in the corrugated industry in about 2 or 3 years. That's hard to realize.
That is true, but I mean, you can see the circumstances in the market are changing. I mean, if you look at gas prices, energy prices, electricity prices, I mean, everything is increasing, and at the same time, if you have, let's say that it becomes a competitive parameter, then of course the converter has a huge interest in being as efficient as possible, right?
Of course, and that must be the goal. But honestly, the gas prices just got below the pre-crisis level. So now the drive is gone.
Yeah.
1 year ago, everybody was shouting, "Oh, we need less energy consumption, less fuel consumption." Right now, because they pay 20, 30 euros per megawatt hours of gas. Nobody's interested in such.
But I take that also from BHS perspective, you keep an eye on the potential of carbon taxes, right? Because if carbon taxes, then energy consumption again becomes not so dependent on what the prices are on natural gas, but how much you pay in tax for it, right? So, yeah. Is that something that you basically, because I mean, I think that one of the biggest issues you have when it comes to, let's say, environmental issues, actually, it's not so easy to measure all the things that actually plays a role in the environmental, let's say, carbon footprint calculations. Is that something that you also, from a technology perspective, help your customers with?
Yeah, sure, because that's the basis. You have to measure, you have to meter to know what you're consuming, because that's a starting point for you to have an optimizations on your system. My colleague Peter Purcell is talking in the Spotlight about the resource monitoring and ICO.
We spoke about him, yeah.
And we see a lot of other players talking about, like Iskada, OpenPack, for example, or other companies who are trying to give the customers an opportunity to measure and to monitor.
Yeah. But is that based primarily on, let's say, kilowatts or tons of natural gas, all these kind of things? The reason I'm asking is just because if you look at, let's say, natural gas, for example, it's called LNG, right?
Yeah. Liquefied natural gas.
Yeah, precisely. Yeah. Basically, when you look at it, you have at least one issue, and that is you can basically see how many tons you use, but you don't know exactly how much emission you have from the same source, right?
You do. You burn cubic meters usually. Gas.
Okay, so you have the formula for doing, but do that calculate that on the machine? Okay, great. Because I was just wondering if that was like, because if you just had like the input but not the footprint, then it would be difficult, right? Okay, that's super nice. But it must be interesting working with, because I mean it is it's high on the agenda in today's environment, and it's of course something that will play a role in the business in the future. So must be fun.
I hope so. Yeah.
No, fun for you, I mean.
Yeah, I do. I'm really enjoying the time, because I just came in the industry in a really like fluctuating time. I was working before for a research institute on heat storages.
Okay. On heat storage.
Heat storage, yeah. And
wow, that is not a bad thing to have when you come in the
that's
BHS.
Exactly,
right?
yeah. And I was working for steel mills, and they got the same problems, getting rid of natural gas. But they got another problem as well. They use natural gas as a material as well, not just an energetic source.
So that was also part of the steel formula, basically.
Yes, exactly. So they're replacing natural gas with hydrogen right now. Okay.
Another thing that I can't help think about, I know it's a little bit maybe irrelevant here, but when you speak about the water, for example, right? You know, if you read about CO2 as a what's it called? What's it called? These gases that you cannot have in the atmosphere.
Greenhouse gas.
Yeah, greenhouse gas. And then you compare it to water. The water is actually worse, because it evaporates in a slower level, right? So it's funny that we talk about something that we exhale, we have something that we consume, and then still it becomes like a hazard to our environment, right?
That's true. Yeah. But that's also like something people should get sensitized to know about the impacts of all those greenhouse gases. And that CO2 is not the worst one. No. There's methane, much worse.
Yeah.
And
there's 7-8 times or something like that.
Yeah,
right?
exactly. Yeah.
But that's why we have the CO2e, right? The
equivalent.
Because
equivalent.
Yeah. Because I think that is, I actually don't think it's a very, very good measurement, but I think it's good in the sense that you get an understanding that there are other greenhouse gases that have an impact on the global climate, right? Okay. Super nice talking to you, Lars.
Yeah, it was a pleasure.
And good luck tomorrow with your presentation. I'm sure you will do good.
Many thanks to you.
Thank you.